In this video lecture, we'll talk more about correlational research designs. Correlational research designs are a large category of research designs that assess relationships between variables. It might be two variables or it might be more than two variables without directly manipulating them. You might also see correlational research called observational research or non-experimental research. The most important characteristic of these correlational designs is that the researcher is not manipulating the variables that they are interested in. So they are observing relationships among variables, but they are not responsible for changing or manipulating the variable that they are interested in. So in contrast to an experimental design, where the researcher is directly manipulating the independent variable, in correlational or observational research, we are not able to draw causal conclusions from our data. So the greatest weakness of our correlational or observational research designs is our inability to demonstrate cause. However, these are really important research designs. They can tell us important things about how variables are associated in the world. They can be great sources of hypotheses that can help us generate new ideas or help us think about studies that we might design that could be experimental. And often they are more feasible or ethical than other research designs. So there are many variables that either we are not able to experimentally manipulate or that would not be ethical to experimentally manipulate. So when we are interested in those variables, often an observational or a correlational design is the only kind of research design that would be appropriate for us to use. There are many different kinds of research designs that fall under this broad umbrella category. One way that we can distinguish between different kinds of correlational research is based on timing. Some of our correlational studies are cross-sectional. That means that we are gathering information at a single point in time and looking at how variables are related to one another at that point in time. We might also do a longitudinal study where we collect information and make observations at multiple points in time. These can be short-term, maybe we are looking over a 24-hour period of time, or they can be very long. We have some longitudinal studies that have followed people for almost their entire lives. And in fact, when we talk about developmental psychology, we'll talk about a longitudinal study that has not just followed one set of individuals over the course of their entire lives up through they are now in their early 50s, but has also taken a look at their parents and also their children. So we have multi-generational longitudinal studies. We can also differentiate among different kinds of correlational designs based on the source of our data. So sometimes we might be using already existing data to look at associations among variables. And we call this kind of research archival research. So in archival research, we are using existing sources of data to generate the data that we use to look at how different variables are associated with one another. A really common kind of correlational design is survey research. And in survey research, we are using questionnaires to gather the information about the variables that we are interested in. And finally, we want to remember that not all of our data is quantitative. So we have talked a lot about different ways that we might generate numeric data to test our hypotheses, but our correlational research might not be quantitative. We might be conducting qualitative research. So we might use methods such as interviews or focus groups or narratives to collect non-numeric data to describe people's experiences. An important concept to understand related to correlational research is the statistic called a correlation coefficient. Now, you might also see correlation coefficients in the context of other research designs. So for example, you can look at a correlation in the context of an experimental study. But a correlation coefficient is a way of representing the association between two different variables. A correlation coefficient can range between -1 and +1. And there are two important things that you want to pay attention to when you're interpreting correlation coefficients. The first thing you want to pay attention to is the sign of the correlation coefficient. The sign of this number tells you the direction of the relationship. You can think of the sign as telling you about the slope of the association between two variables. If the sign is positive, this means that as one variable increases, the other variable also increases. We call this a positive correlation. If the sign is negative, if there is a negative slope between the two variables, this tells you that as one variable increases, the other variable decreases. You might also sometimes see this described as an inverse correlation. If the correlation is 0, that tells us that the slope is 0, that there is no systematic association between our two variables. The other important part of the correlation coefficient is the magnitude. So remember that a correlation coefficient can be between -1 and +1. A correlation of 0 tells us that there is no systematic relationship between two variables. The closer the magnitude of the correlation coefficient is to either -1 or +1, the stronger the association is between the two variables. So a correlation coefficient of either -1 or +1 means that two variables are perfectly related, that if you know the value of one variable, you can predict with 100% accuracy the value of the other variable. And if you graphed those two variables, they make a straight line. Now, the farther away from a straight line these spots on our scatter plots get, the smaller the magnitude of our correlation. So in this figure, you can see that all of our negative correlation coefficients have a negative slope, and our correlation of -1.0 looks like a perfect line with a slope that is going downwards, and that as the magnitude is getting smaller, as we go from -0.9 to -0.8 to -0.7 and so on, that our observations are getting more spread out around this hypothetical line. And we see the same pattern, but with a slope going in the opposite direction for our positive correlation coefficients, that our correlation of 1.0 is a perfect straight line with a positive slope, and that the correlation coefficients with a large magnitude, like a 0.9 or a 0.8, are very tightly clustered around a line. And as our correlation coefficients are getting smaller in magnitude, so for example, around a 0.4 or a 0.5, they are more broadly clustered. And as we get to our small correlations, so a 0.1 or a 0.2, we are getting kind of this really big spread, even though we still have this positive slope. So to interpret our correlation coefficients, we need to pay attention to both the direction, so the sign of the correlation coefficient, and also to the magnitude, so how close that number is to either +1 or to -1. Now, you have probably heard this phrase somewhere, that correlation does not imply causation. So sure, we've all heard this, but why does correlation not imply causation? And what does that mean? So when we say that correlation does not imply causation, what we mean is that a correlation or an association between two variables is not sufficient evidence for a causal relationship. That just because two variables are correlated does not mean that one variable can be said to be causing the other. Now, why not? Why can't showing a correlation tell us that a variable is causing the other variable that it's correlated with? Well, one reason is that a correlation coefficient cannot tell us about the direction of the association between two different variables. It can't tell us whether variable A is causing variable B, or whether variable B might be causing variable A. If we think about the association between sleep and well-being, it's possible that getting more sleep causes higher levels of well-being. That something about the benefits of sleeping leads people to experience various positive outcomes. It is also possible that people who are experiencing higher levels of well-being may get more or better sleep. So perhaps people who are in a better mood are more likely to engage in healthy behaviors like getting a good amount of sleep. So a correlation coefficient can't tell us the direction of the association between two variables. And we also have what we call the third variable problem. So if two variables are related to one another, One possibility is that one of those variables causes the other. But another possibility is that both of those variables are being caused by a third variable, a variable that you have not measured, and that the relationship between that third variable and the variables that you have observed is the reason that your variables look like they are related to one another. We call these third variables confounding variables. So these are variables that are related to the variables that you are interested in that make it look like there is an association between the variables that you are measuring in a way that is inaccurate and that doesn't actually represent the true association between those variables. So to illustrate this, I am going to show you an example of something called a spurious correlation. This is actually an example that was shared by someone in our class. So this is a graph that is showing us the association between the average consumption of margarine by individuals in the United States per person between the year 2000 and the year 2009, and the divorce rate in the state of Maine during the same period of time. So in this graph, we can see that over the decades starting in the year 2000, that we've got a decrease in per capita consumption of margarine, starting out at a little bit over 8 pounds of margarine per person per year in 2000, and decreasing to less than 4 pounds per person per year as we are getting towards the end of the decade. We can also see in the red bar the divorce rate in the state of Maine. So this, I believe, is the number of divorces per 1,000. It's either residents or marriages. And you can see that over the same period of time, this divorce rate is also decreasing from about 5.0 in the year 2000 to a little bit over 4 at the end of the decade. And at the bottom, you can see that the correlation between these variables, often you'll see this abbreviated with a lowercase letter r, is 0.99. Now remember, when we talked about the magnitude of correlations, we said that the closer a correlation is to 1, the stronger that association is. So this is an almost perfect correlation. There is a very strong association between how much adults in the United States are eating margarine and how likely couples are to get divorced in Maine. Now, if you were a newspaper editor, you might take this information and you might go publish a study and you might say, did you get married? You should stop eating margarine because if you don't, you're going to get divorced. But you might have already picked up on the fact that that sounds a little bit silly. So just because we see this very strong association between these two variables does not mean that there is a causal association between eating margarine and getting divorced. Perhaps we have a directionality problem. So maybe people who get divorced are more likely to start eating lots of margarine. More likely, we have some kind of third variable that is producing this association. So perhaps this has something to do with the strength of the economy. Maybe when the economy is strong, people eat less margarine and more real butter, and are also less likely to get divorced because maybe it is less stressful in a relationship when the economy is doing well, and maybe experiencing more stress might contribute to divorce. So if the economy is doing well, people are eating less margarine, they're less stressed, so they're less likely to get divorced. When the economy is doing poorly, people eat more margarine, they're more stressed, and they're more likely to get divorced. That's one possibility. Another possibility is that maybe we are seeing different changes over time that tend to look similar. So for example, perhaps we have different attitudes towards different kinds of food and different cultural trends in terms of food consumption that are leading people to eat less processed food and eat less margarine over time. And also, perhaps over time, we're seeing changing patterns in relation to marriage and divorce. So perhaps fewer people are getting married, resulting in fewer people getting divorced. So maybe when people are breaking up, if they didn't get married in the first place, you wouldn't see them in your divorce rate. So maybe this is simply the effect of two different processes that are changing over time, looking to be associated with one another when really they're reflecting two very different underlying processes. So this is an example of a spurious correlation where we have a statistical association between two variables that if we let it mislead us, we might make some conclusions about causal associations between those variables that would be inaccurate. I'm going to share another example of an observational or a correlational study looking at the association between sleep and well-being. So we're going to look at some findings from a study called Sleep Quantity and Variability During the First Semester at University, Implications for Well-Being and Academic Performance. This is a recent study. It was published in 2022. In this study, they observed 97 college students. All of these students were first-year students. They were all students in an introductory psychology course. 60 of these students were women and 37 of these students were men. And this was a longitudinal study. So in this study, each week the students completed a weekly assessment. Every week they were asked to report how much they had slept during the weeknights of the week before. And they were also asked to report how much they experienced two different emotions over the past week. They were asked to rate how often they experienced happiness over the past week on a 0 to 6 point scale, and they were asked to report how often they experienced anxiety over the past week on a 0 to 6 point scale. The first finding we're going to look at is the association between their average weekly sleep during weeknights in hours and their average level of anxiety that they reported over this 15-week period of time. So what you can see here is that most of our students are getting somewhere between 6 and 9 hours of sleep. And we can see that if we try to put a line that is going to get us close to all of these different observations, that the slope of this line is negative, and that our observations are pretty scattered around this line. So the correlation between these two variables in this study was negative 0.31. So this was a statistically significant correlation. These variables are associated with one another. It's an inverse correlation. So as average weekly sleep increased, students are reporting lower levels of anxiety. And this correlation is in the small to moderate range. So it is not very close to 0. But it's also pretty far away from -1. So this is a relatively small inverse correlation between average weekly sleep and the level of anxiety that these college students are reporting. In this figure, we can see the association between this same variable, so the average amount of sleep that these college students reported getting on weeknights over this 15-week period of time. But now on our y-axis, we've got the average level of happiness that they reported over this 15-week period of time. And here we can see that if we draw a line through these observations, that the slope of this line is going in the opposite direction. This is a positive slope. And the correlation between these two variables is actually the exact opposite of the association that we saw between sleep and anxiety. So the more sleep that our college students reported getting on weeknights on average, the higher levels of happiness they reported each week during this 15-week period of time. So this is a positive association. Our correlation coefficient is positive. And this is also a small correlation. So the magnitude of 0.31, it's not super close to 0, but it's also not a very large correlation. So this study is giving us observational evidence that sleep is related to well-being, that getting more sleep is associated with experiencing lower levels of anxiety and experiencing higher levels of happiness. We need to be really careful about how we talk about these findings because this is an observational study. So we can't draw causal conclusions from this data. We can't say that sleep causes people to be less anxious. And we can't say that sleep causes people to be happier. One possibility is that this is a directionality problem. Now, in this study, because our data is longitudinal, we could try to look at associations that would help us know which variable came first and which variable came later. So we could try to look to see whether sleep early in the semester is associated with higher levels of happiness or lower levels of anxiety later in the semester. So sometimes we can start to try to figure out this directionality problem, but even if we can address the problem of directionality, we still can't address the question of whether there are other confounding variables that might also lead us to see a correlation between these two variables. So unless we had an experimental design, we can't draw any conclusions about the causal relationship between sleep and well-being. But even though we can't draw causal conclusions from this data, it's still a really interesting study that can help us understand some important things about how sleep is associated with different characteristics related to well-being. If you're interested in more examples of spurious correlations, I encourage you to check out Tyler Vigen's Spurious Scholar Project online at tylervigen.com. He also has a book that illustrates many of these really interesting spurious correlations. So if you want to see more examples of how statistics might lead you astray and how to practice not being caught up in these inaccurate interpretations, I encourage you to check these out for more examples of spurious correlations that definitely do not reflect true causal relationships among our variables.